The Internet is an extraordinarily complex creature, using a wide variety of hardware and communication protocols. To help make sense of it all, most any discussion of networking begins with the notion of interconnection layers, an idea that captures the most important relationships among the Internet's components. Several attempts have been made to formalize these, most notably the 7-layer OSI model and the 4-layer Internet Protocol Suite. We'll use a hybrid model here and try to keep the discussion intuitive. The physical layer refers to hardware that actually creates and transmits the electronic and optical signals, as well as the protocols for interpreting these signals as bits. This would include the network interface card inside your computer, the modem that your internet service provider gave you or recommended that you buy, the Ethernet cable connecting your modem to your computer, and even submarine fiber optic cables that stretch across the world's oceans. Protocols for interpreting the signals sent across these media include physical Ethernet and SONET. The link layer governs the communication between peers on a local network. The most trivial topology for a local network is just point-to-point, where there is a permanent link between two endpoints. We can also have more complex topologies, however, where multiple nodes are all connected to the same medium and feel all each other's signals. The challenge here becomes making sure that they don't all talk at the same time. The link layer also encompasses switching, where connections between nodes are made on an as-needed basis to reduce the potential for crosstalk. The network layer is responsible for end-to-end communication on the Internet. When you request a page from the Udacity website, the data doesn't come directly from our servers, but goes through several intervening machines. This process of routing the data, or figuring out what path the data should take, belongs to the network layer. Unlike other layers, which have evolved to include many different technologies, the network layer is governed almost exclusively by the Internet Protocol and the system of IP addresses. Now, once data reaches your machine, there has to be some way of knowing which application it is intended for. Also, communication isn't perfect, so we need some mechanism for detecting when data goes missing, arrives out of order, or when the connection is overloaded. Coping with these situations is the job of the transport layer. And lastly, at the highest level, we have the application layer, which includes application-specific protocols such as HTTP for web, SMTP for mail, etc. The relationship between these layers is mostly one of using. The link layer uses the physical layer to accomplish its goal of enabling point-to-point communication across a shared medium. The network layer uses the link layer to accomplish its goal of end-to-end communication between two machines on the Internet. The transport layer uses the network layer to accomplish its goal of reliable end-to-end communication between applications. And the application layer uses the transport layer to accomplish its goal, whatever it may be, whether it's fetching a website, sending an email, or streaming a movie. The plan for this lesson will be to start at the bottom layer and move our way up.